Hello, good evening, good afternoon, good morning, wherever you're tuning in from, and welcome back to my channel. And this is For the Love of Chemistry. Okay, so today I wanted to do more of gas laws, but I realized that most of the questions I saw on Jambs and WAEC require writing of equation for the reaction. So I realized it would be a disservice to you if I do not teach in details how to write equations and write them very well. So today we are going to look at this. This is a universal problem with most people that are offering chemistry. Most of them are not good with writing equations. And for you to really get everything you need, you have to be very good with writing equations. So today I'm going to jump right into it. So looking at this board, you can see that I wrote out different elements, majority of them, not all, but most of the elements you would see in many chemical reactions and equations you'll be asked to write, and their valencies. And the reason is simple. For you to even write any chemical equation, the first thing is to know the symbol of the element you are writing the equation for. So here we have the names of the elements and their symbol. For instance, if you are asked to write the equation of a reaction involving, let's say, aluminium, the first thing you will need to know is the symbol of aluminium. So if you don't know the symbol of aluminium, like you don't even know where to start the equation. And one thing I must let you know is that your reactants are the same as the product. The elements of your reactants are the same as the elements of your product. The only difference is that they are arranged differently. There are breaking of bonds, there are formation of other bonds. But there is no existence, at least in a chemical reaction, not, of course, in nuclear reaction, we have a production of an entirely new element. But as far as chemical reaction is concerned, you do not have a different product from the reactants. You don't have a different element existing in the product that is not in the reactants. So have that at the back of your mind, that whatever you are told reacted with whatever, the products will be the same elements arranged in a different form. And very soon we will see how simple this is. So please, if you are just new, maybe you are in SS1, you've been taught this, but it's not yet clear to you, I'm here to make it very clear. So the first step is to know the symbol of the element. For instance, if you're asked to write a reaction of aluminium, let's say with let's say I want to do an element and an element. What can aluminium react easily with? Or let's say with oxygen. Okay, the first thing you should know that we said aluminium, right? So you write aluminium. This is the symbol of aluminium. Now for the state, is aluminium a solid, a liquid, or a gas? Of course it's solid, unless of course heated, but we were not told that it was heated to a certain temperature and it became liquid. If you are told aluminium, just know aluminium is normal, occurs naturally, or sorry, from extraction as a solid. So we write S, indicating that it's a solid. So you've gotten the first reactant. Now we are told that this aluminium reacts with oxygen plus oxygen is capital letter O, not small letter O. Now, let me go back to aluminium just a bit. Aluminium exists as a monoatomic molecule. What do I mean? A single atom of aluminium can exist on its own. That is why when we wrote Al, that's it. We are done with writing our aluminium. Now, but when it comes to oxygen, oxygen does not exist alone. It combines with another oxygen to form a molecule of oxygen. So O plus O, that's O2. You put that 2 as a subscript to show that this oxygen is not just one atom of oxygen. This is 2 atoms of oxygen. And here, this oxygen, is it a solid, a liquid, or a gas? It's a gas. So we write gas. So have you seen that just knowing the symbol of the element will get you to a place where you can at least write the reactants once you are told what reacted with what. Now, we get to the product. Remember I said the product does not fall from heaven. The product will come from these 2 reactants. So usually metals are written first before the non-metal. So if this is combining with this, it's like this is a combustion reaction, because any reaction with oxygen is a combustion reaction. So aluminium burning in oxygen to form aluminium oxide. Now, this is not yet correct. Please look at my symbols. Let me write this in a more. Look at my symbols. I did not write capital L. The first letter is capital. And the small, any element that has 2 letters representing it, the first one is written in a capital letter, the second one is small letter, uppercase, lowercase. Please, don't write this. You see people writing something like this. Don't do that. It pricks my eye. So don't blind me. Okay, so now we've written aluminium oxide, but this is not yet correct. Then that brings us to valency. What is valency doing here? It comes into play when you're writing the product. So when these 2 combine, there is what we call exchange of their valencies. So the first thing you will do is to get, what is the valency of aluminium? 3. What is the valency of oxygen? 2. So what they do in combining is that they exchange their valency. Oxygen gives 2 to aluminium, while aluminium gives 3 to oxygen. So this is the correct symbol of that element. Okay? So, but it doesn't stop there. Now, this aluminium oxide, is it a solid or a gas or a liquid? Of course, it's a solid, so we write S. But that is not the end. We will have to balance the equation, because you know the atoms here must equal the atoms here, so that the law of chemical energy please, my mouth is not trying to pronounce that. You know what? Chemical please, I will say that later. So, aluminium combining with this, the atoms here must be equal to the atoms here. So, the law of chemical conservation, hey God, will be respected, because atoms are neither created nor destroyed in a chemical reaction. So, the number of atoms here must equal the number of atoms here. That is why we balance the equation. So, if we have 1 aluminium here, or we have 2 here, so let's make it okay. 2, we have 2 aluminiums here and 2 aluminiums here. But we have 2 oxygen atoms here and 3 oxygen atoms here. So how do we do it? If we add 3 to this place, we have 6 oxygen atoms here and 3 here. So if we add 2 to this place, we have 6 oxygen atoms. Let's check all over again. We have 2 aluminium, but 4 aluminium here. So we change this to 4. So let's see if our equation is now balanced. 4 aluminium atoms. Remember, you multiply the atom and the mole to get the total number of atoms. This time this is 4, this is 4, this time this is 6. This 2 in front of this governs everything here. So that means everything here is being multiplied by the 2 in front of it. So it's not just for aluminium alone, it's also for oxygen. So when we multiply 2 by this, we have 6. This is 6. So the equation is now balanced. and you have just written a balanced chemical equation for the combustion of aluminium and oxygen. How is that? Very simple, right? Okay.